Okay. Alright, so what I have here on the bench is the PCB for my project, the Stereopathic Oyster, which is a stereo filter. This concept basically is just two filters running parallel, and you can run a mono into it, and that would output as stereo, or you can give it a stereo signal and it processes that in each channel. So I just wanted to make a video where I capture me assembling this PCB. There's a faceplate and everything. I don't have that here on the bench at the moment, but just diving right into it. I have what I've kind of created is a build of materials list, and that shows me what the components are and their footprint reference on the PCB. I've got all those materials laid out, and I've organized them so that I could pretty quickly move through into the different parts as I assemble it. I've been assembling PCBs, building my own projects now for several years, and I've gotten a little bit of a system down to it. But I'd say every time I take on a new project, there's the possibility of making improvements with how I do things. And that's kind of like what I wanted to do with this video here, where I end up having a documentation of the process, and hopefully no errors are made, but if I make an error, I can see where I made that error and maybe learn from it a lot better by having this video edited and put together. I also plan on using this video to share on the internet, and sort of in documenting the process, but also in helping promote the concept to perhaps when it's on the market, to just educate any people who would be interested in purchasing this concept. I'm only going to build a few of them. I only have enough parts to build a few of them, but that's really all that I ever get to anyway with these kinds of things. I'm not like mass producing stuff, but usually just building enough to get rid of the extra parts I purchase when I would buy small quantities of things. Usually parts and all, when you need parts for something, it's very expensive just to be buying just one of something if you only need one, and you usually get discounts on parts when you buy them in bulk, at least of 10 or more. So because of that, I usually have enough to build a few of something that I wanted to assemble. So what I have here is the list of the parts. I got my circuit PCB, I've got all my resistors, and they are the quarter watt, and they're blue, which means they have a 1% tolerance, I guess that's what that's called. And with building something that kind of requires precision to it, like an audio filter, and having two audio filters side by side, even the slightest variances in certain components can affect the sound of your stereo signal. So with this project, I'm using these style with the 1% tolerance. These are metal film instead of the carbon film, which are the tan resistors, which have been in the past usually what I use. And for gain circuits and just general audio circuits, you can kind of get away with that. But with this project, I really was trying my best to make something that was as tight and balanced and symmetrical as possible. I have my potentiometers, I've got my sockets, I've got my sockets for the ICs and sockets for the jacks, for plugs, ins and outs. I've got all my capacitors, my diodes, and some electrolytics here. The tools that I would use for this, I have a soldering iron off in the corner here, just a pretty typical corded. And for cleaning the tip, I like to use one of those like gold colored metal mesh, not a wet sponge, but the metal mesh. That seems to be the best way to keep a tip clean. Like, it's been heating for a while and it's pretty corroded looking, and you get the best action when your tip is nice and shiny. And I just like to use that sponge material to keep it shiny in between each time I go to work with it. I use these little snips here. They're like little angle snips, and I also have a pair of little needle nose pliers with a little bit of the grippy grips in there. But I think I've got everything. Oh yeah, I like to use eye protection for various reasons. When snipping the leads off, sometimes those things will shoot, and I don't want anything like that hitting my eyeballs. And also with soldering, there's rosin in the solder, and sometimes when you're soldering it splashes, and I just have a lot of irrational fears, like maybe this stuff when it splashes, yeah sure it's molten hot when you're sitting there at that real close point there, but when it comes splash out here, it cools off, and maybe it's getting in my eyes and I don't even feel it, like tiny little like little bits of it, like not the metal, but like the rosin inside that is helping the metal bond to the other metal surface. And yeah, I just try not to mess with that. The solder that I'm using, I forget what the number of it is, but this is the lead-free kind. It's Kester, and I prefer to use lead-free with just for health reasons. Lead solder is preferred. I hear a lot on the internet, especially with old school, older electronics kind of guys. Definitely trash talk the lead-free stuff. But I've never had issues with working with it and its ability to flow and resolder, work with lead-free. Maybe the older stuff was a little bit more of a pain in the neck, but for all of my concepts, I tried to reduce the amount of lead at all costs possible. The PCBs, all these metal surfaces, I opt for the option to have it be the lead-free type of surface finish for those metal spots, and then I use the lead-free solder. And as after that, I mean, any other parts that do have any amounts of lead in them, I'm unaware of, but I have my suspicions about maybe even like things like the leads on certain parts or whatever. Now, I guess I could take it a step further and wear latex gloves or nitrile gloves, but I'm pretty on it with washing my hands after I handle this stuff, as to not contaminate my living spaces with that kind of exposure. But anyway, I think I've got everything set here. So now for the assembly process, my iron's hot. I guess when it comes to a board, I got my little helper hands here. This is a little Radio Shack unit I bought when I was a teenager. Some OG equipment here, but it still does the job. And yeah, I regularly use it with this kind of work. They make real nice ones with like 4 arms and all that. And I've been interested in upgrading, but this one still just gets the job done. I also put heat shrink tubing on the tips of the little alligator clips so that the teeth in them wouldn't maul up my PCBs when soldering them. So I guess the first thing I should go about when doing a PCB is the lowest profile parts, which if I'm not mistaken, I think it's going to be these IC sockets. So what I'll do. Oh yeah, another tool I like to use are these like these plastic like pointer like tools. I think they're called spudgers or spoogers. I don't know, but I've got a collection of them, and they do wear down, but they've got a nice pointy tip and a nice little flat tip here. And I use these for bending the parts down. I don't know why I took that off the helping hands. I guess because there is like a. I guess maybe I should do it like this. Okay, so now this one is a 16 pin, and that is right here. Get that pushed in. Okay. And usually what I like to do is just bend. I'll try to flip it to show the process if I can do it without losing it. I keep my finger on the back side of it, pushing it down so it's flush as much as possible, and then I can bend the sometimes you can just do opposite corners like this side and this side or whatever, but I'll just do the 4 outside corners, just bend the tabs over, and that'll keep it from falling around if I have to move this a few times to get everything situated. I only have one 8-pin, and the footprint shows a little divot, and the socket has a little divot, and that's to help keep straight your pin orientation as to what pin 1 is on your IC. So bend my tabs. I've never done this before where I sit here and talk while I assemble. It's usually a very quiet process. I don't like to listen to music or watch videos. I just work in silence, as silent as it can be. Yeah, that's good. When designing and laying out a PCB, you have a lot of decisions to make with how you can place things, and there are a lot of different ways to approach that. There's circuit design consideration where you don't want a whole bunch of vias and a lot of just sloppiness to potentially increase the amount of noise or issues with your signal flow in a circuit design. There's also too the consideration of how you assemble it, and there are things that you can do to make it a little bit less of a pain in the ass when you're doing your assembly. And the more I've done this, the more I've kind of picked up little tricks and things that seem to help me. If you have everything kind of scattered about and oriented in all different directions, it's real easy to accidentally goof up. If you have them all where pin 1 is, let's just call that north, and then you had one where it was south. If you didn't get enough sleep the night before, you just glitched and you accidentally had it flipped, and you have it all soldered together, and you have a problem, and then you realize oh, I had them all sticking up, but yet the actual way it's oriented is the other way around. And so you try to keep everything sort of oriented in the same sort of way, the ICs all sort of pointing up, but really that's not so much an aesthetic thing, since this is a circuit board, but just for the assembly. And also with footprints being easy to read, I can see a couple places where I've got a couple little goofs where maybe two different footprint labelings have overlapped, and so it's blurry, or you can't make out what they say because it's letters over top of one another. Or over here I see one of the footprint values, the R is actually covered up by one of the solder connections, but I can still tell. It looks like it's an R8 there for this one. Alright, so those are all in, so let's solder them. And to keep these all flush, I'll do that, and that way the weight of the PCB keeps them, because sometimes if you do it like this and you put it upside down, they can kind of fall, and then when you turn it around, you've soldered it, they're not actually flush. Maybe one of the corners is bucked up. So and that's kind of a pain in the ass when you put all that time and energy into the assembly process and something looks crooked or isn't seated fully. Alright, so I've got all that. Alright, so I'll do the soldering now. Stick this guy right here. Turn that on. I didn't drink a lot of caffeine this morning. I only had a cup of tea. I suppose really the more caffeine that you consume before you do work like this, the more likely you'll have shaky hands. And I suppose some people just have shaky hands just naturally or whatever, but some days I'm good, some days I got the shakes pretty good, but I think there's a lot to do with just what your caffeine intake is. When I solder these sockets, if I was soldering an IC directly, I would be very considerate of my time it takes me to get all the joints soldered and the pattern in which I do it. Kind of alternate sides is one technique where you don't want to apply too much heat in an area of of like a semiconductor, like an IC, for concerns of like maybe like damaging it. But with the sockets, you have a little bit more leeway. If you leave your solder connection on there, if you leave your soldering tip on there too long and take too long to solder it, say for instance you have a lot of corrosion on your tip and it's just not heating it up good, and you're not getting a good connection, and you're fussing with just one little solder point, you could be heating up the plastic of the socket and cause distortions in it. But I'm using sockets on it. Normally I like to use, I feel confident enough to put ICs in PCBs without sockets. If I can do that, it's what I like to do, because then you don't have to worry about any type of corrosion in those connections down the road and having issues with the circuit. But with something like this, I'm only building a few of them. It's nice to be able to kind of give yourself a little protection during assembly, where you put your ICs in right off the bat, and it just feels like you have more likelihood of damaging them while soldering other stuff, or since this is an early build, if there was any mistakes with the assembly process, or if the PCB design has an error in it, it's a real pain in the ass to have to desolder your chips. And op amps aren't that expensive, but this has a quad VCA chip, and those are kind of expensive. Probably the most expensive chip I've ever worked with. I can only buy them in small quantities, but they run about $6 a piece, and just buying 4 of them plus shipping, you kind of gets up there just to just get a couple chips in the mail. So the sockets are nice because you can kind of get all the majority of all the work done. Sort of for me, I like to make like the final step for assembling the PCB, putting those ICs in. Feels like there's just less likely of damage or whatever with handling them. I don't use a anti-static mat or anything, and that is a concern or whatever about like I don't know, like static shock cooking a chip. I can't say I've ever experienced that in the years I've been doing this, but I'm not going to dismiss it as a concern. So that's why I try to like reduce how much I have to handle the ICs. If this was something I had been building a whole bunch of, I probably would get to a point where I wouldn't even use sockets. I would just solder the ICs in at the last stage, even though they're the most low profile part. A lot of times the resistors would be if I was orienting them horizontally, but I orient all mine vertically so they stand up. Alright, now let me inspect, make sure I got all my connections here. Okay. Looks good. Clean the tip, just put it back in the little holder. Turn that off. Alright, I'll do the power supply, the diodes in the power supply down here. And these are, what are these? These are 1N5819s. These are good for protecting the from reverse polarity, in case somehow or another you have a connector that doesn't have there's possibilities of you could have it connected on here fine, but when you're connecting your power ribbon to your bus board, your power supply bus board, sometimes those things, at least with all of mine, they don't have sockets on, they just have the pins sticking out. So it is possible to stick the power connector in backwards and have your plus and your minus opposite. And so with putting reverse polarity protection in your power supply on your design, you can protect your circuit from getting that incorrect power connection, which could fry your, some parts on there, probably like ICs or something. So what I do with these are, or I have the diodes mounted horizontally, and I like to take my needle noses, and these have little teeth in them, and I go back a couple teeth, like to the second or third one, and that gives me a certain spacing, and I just push it down, and that way I've given a little bit of space on there, and they're uniform. Stick it, snaps in there. See, made a mistake sitting here talking, or did I do it wrong? Yeah, I did. See, I think talking is also kind of like a handicap with the assembly process because you're not fully focused on what you're doing. But diodes have a band on to let you know their, which way the electrons flow through them. And these are, the footprint shows what side the band should be on. Okay. And there we go. And so I could just flip this. So what I do is I take this tool here and I bend these like that, and that keeps them from falling down through for when you go to solder those in. I won't solder them in immediately. I will carry on through. I guess I'll do the other diodes now. Alright. Same thing with these. Use this needle nose to give a little bit of space and then bend the lead down. And on the footprint here, both of them have the stripe in the same orientation, so they will both line up. These are 1N4148. These are pretty common diodes. Okay, they're flush. Alright. Let's see. Sometimes in the past I would use a highlighter to mark off the things that I've seeded so I can kind of keep track of what I've done. And since I'm left-handed, this is kind of awkward. I should actually have this sheet of paper on the other side. Alright, so next we will do, I guess we'll start doing resistors. So I got some down here. I got R43 and R44. So R43 and R44, both 10 ohm. Okay, these are in the power supply. Oh, how is that? Is that... There's I only need 2 of those, and I see I've got a group of 2 here. Now, when I was using the carbon film resistors, or carbon wrap, or whatever it is, the tan ones, I had all those color bands, not all of them, but I had a lot of the common ones that I was using memorized after a certain point, and it was pretty easy for me to identify them. But with these blue ones, the color bands are like different or something. I haven't memorized all of them. Some of them are kind of familiar, but I don't know. The colors don't really pop off the blue very well for me. So a technique I learned along the way watching some YouTube videos was just the fact that, like, imagine if you were colorblind. Like, the color bands are irrelevant. So really the best thing to do is just measure them with a multimeter. So these are 10 ohms. So let me put that. I should be good for that. So I'll just check to make sure these are 10 ohm. Yeah, those are 10 ohm. Cool. All right. And these are vertically oriented, so I only have to bend 1 tab down. Like that. Yeah, put it in there like this. Now, when putting these in, since there's so many resistors, sometimes I stop halfway through and solder them up and then trim off all the leads, because after a while you start to get a lot of these leads kind of overlapping, and it can kind of get a little difficult to get your soldering iron down at those spots to solder. So if it didn't have as many parts, or as many resistors, I would just wait till I had them all populated before I did that. Oh, phooey, this thing's gotten loose. There we go. I was kind of wondering how long this video would be. I've actually had this project on this bench now for probably 3 weeks, all set to go, and I've got other things going on in life that are kind of occupying my attention and time and all that, but I think the idea of capturing this and how I was going to do it was pretty daunting, and I think that's probably one of the reasons why this has just been kind of in stasis for so long. I could have had this done a month ago, it seems like. Next, R2. I'm going to just take and highlight these. R2, 47K. Double check. R2, 47K. How many 47Ks do I need? There's 6 of them. I bet you that's these up here. Here's R2. Just cut the... and we'll double check. Give me... Yep, 47. Okay, bend the lead down. Now the footprints have like a little white circle around them to orient what side the body of the the resistor would be in. But I mean, you can go either way. The orientation of that doesn't matter. But when laying it out, some of the footprints will be, the white circle will be on the left side. Some of them be on the right side. But I like to kind of try to keep them all in the same direction for solidarity and look, where they're all sort of oriented the same. But I mean, it's a tedious detail. So R2 is done. What's next? See, R3 and R4. R3 is 100K. R4 is a 20K. So R3 100K. I think that's these. I'll probably end up checking every single one of these until I know of my pile what each value is, but you definitely don't want to have an error of like one resistor being the wrong value, because that may result in not necessarily a catastrophic error where it won't work, but it just will have some sort of quirk that could take a while for you to catch in testing. But I've already been working with the prototype now for probably almost 2 months, and there shouldn't be any issues with any of these values unless I get them, I put it in the wrong spot. So I'm just trying to be careful with that. So R3 is 100K. R3 goes right here. Bend the lead so it doesn't fall out. And then R4 is a 20K. And that should be, I only have one of those. That's this one. Yep, 20K. R4, 20K. Yep. Oops. I'll put it in this way. Okay, we'll get to that. Okay, mark those off. So I guess the pattern I'm going with now is just sort of populating it by the working from the front to the back. So I'm just kind of looking for wherever the next resistor is. So now I could go over here. I see R33. Here's R1. I'll do R30. I'll do R1. R1 was a 47K. Those are up here. Check. Yep, 47K. Shouldn't have to do that too many more times. 47K was R1. R1 is right here. I wonder how the audio on this will be like when my voice gets quieter, if that's picking that up. I'm using this camera's microphone. So next, let's do R33. Let me mark off R1. Now with this, taking a highlighter and marking it off like this, it helps me keep track of what's been done, what hasn't been done, and that way if there's a part that's missing, or it's just another step to kind of help keep track of what you've accomplished and to reduce the likelihood of an assembly error. So the next one was R33, right there. R33 is 470 ohm. R33, 470 ohm. Let's see, where would that be? It was there's 4 of them total. So here's a group of 4. So now I'll cut that. And I gotta change the value. Oh, it's too small. 4, yep, that's it. R33. So now I see R21. R33, I'll scratch that one off. Next one's R21. R21 is another 470 ohm. 470 ohm. I don't need to measure that because I already measured these and pulled from this group. So R21, 470 ohm, R21. Alright, now I got, let's see, R19 and R30. Where are any of those? Let's see, R21. R19 is a 30K. R30 is a 30K. So where's 30Ks? They're about in the middle. There's 10 of those. So here's, looks like a group of 10 resistors. So those are probably the 30Ks. So R30 and R19, just double check. That's a 30K. And that's a 30K. So I need 2 of them. Yeah, now I'm doing this and getting a little bit of a flow. I kind of realize that it's kind of a pain in the neck to have to, when I'm working from the front to the back, because as I get to the back, it's going to be harder to kind of work with all those. Where if all these were in the back, I could still have clearance in the front and just work my way to the front. I don't think it's a big deal, but maybe that's kind of like one of the reasons of doing this video, is by documenting it and actually like narrating it and talking. I can sort of create notes of the process, and maybe in the reviewing of it, by editing it, I'll have a better chance at remembering those kind of steps of, like, maybe that'll make assembly easier if I kind of approach it that way with future builds. R19 and R30. Yeah, this concept has over 100 parts, 102 parts on here. Resistors, there's R44, so there's 44 resistors. I've had projects with more than that. This isn't too bad. It's a lot of resistors, but not too bad. Alright, so what's next? Let's see, R14. Oh, that's another 30K. R14, double check, is 30K. Boy, if I design this with surface mount parts, like for the resistors and the film and ceramic caps, assembly would be so much quicker. I mean, it would be ICs, because I would keep well, I guess I could do the op amps as surface mount too. And then the quad VCA chip, they make surface mount versions of that. But I mean, I don't think the assembly, the board manufacturer carries those, but definitely covers these quad op amps. This is a dual op amp. That could also be surface mount. Yeah, it would only be so many things I would actually have to populate on here, and building these would be a lot quicker. So 14, did I push those? Yeah. R17, let me mark off R14. R17 is another 30K. Another advantage too to using surface mount, other than just a faster assembly, would be the reduction of making errors, where like I could accidentally skip a beat here and put a resistor in the wrong spot. I mean, that can happen. I try to take my time, and it doesn't happen very often. It's happened in the past, but it's been a while. But that can happen, and the more parts you have, the more of an increased likelihood of that occurring. So, you know, if you went with surface mount, you'd have far less likelihood of having an error in your parts layout, or your parts in assembling your PCB. Alright, so I want to go over to here. Let's see, we have R16. So I just did R17. So R16 is also a 30K. Here's R18 right here. That is also a 30K. Here's R20. That's also a 30K. And then R22 over here, which is 470 ohm. So I'm just going to do these three right here. R16, R18, R20. 16, 18, 20. They're all 30K. Should I be talking? Seems like if I talk, there's more of a chance of me screwing up. But it's also kind of boring just to sit here and be in the quietude of just seeing me assemble. I feel like I'd be tempted to want to speed that up. I mean, do we need to see every single resistor getting populated? Or at least see every single resistor getting populated in real time? I don't know. R22 is a 470 ohm. And then I believe that was these guys. And I'll double check. Yeah. R22. Yeah, we're still good. Next one. Let's stay over here. I got R30. I got R40, R32, and R34. R34 is a 470 ohm. Okay, another one of those. R32 is a 30K, and R40 is a 470K. So back up to here. R34 is a 470 ohm. I think that's the last one of those. Now, the reason I've been doing this now for a while with the PCB designs where I do the resistors in a vertical orientation. It seems like I can fit. It just gives me more room on the PCB to work with. You can still run traces underneath them if you have to. I try not to do that, but with making them vertical like this, it seems like I can kind of have a little bit more freedom with getting them closer, designing it so I can get those parts closer to the ICs and reduce trace lengths and be able to get more parts in a smaller area, where if they were horizontal, it does take up a lot of room. And when you have a project with this many parts, you know, real estate is you know, how you lay things out is pretty important. All right, so R34, let me just mark that one. Now R32 was a 30K. That was these guys. Let's pop that out. R40 was a 470K. And I think that will be these right here. Just double check. Yes. Bend leads. Cool. Mark all those. R34 done. R32. R40. Do R15. R15 is a 30K. Oh man, we're getting about halfway done the resistors. R15. Alright. Cool. What's next? that was R15. So this is R31, 100K. How many 100Ks do I have? 5 of them. I think that's probably up here. Yeah, I already did one of those. R31, R31, 100K. R36. That was R31. Mark that off. R36 is another 100K. I guess it would be beneficial if I just kind of looked around the nearby parts, but they aren't always going to be the same values. R36. And it's easy to kind of get things mixed up when you start trying to do 2 or 3 resistors at once, and they're all different values. You start getting their the footprint number, like R34, and then or R30, and then you're looking for a 30K, and you can get things mixed up. So R36 was 100K. So next, let's see, I see R12. R12 is a 300K. There's 2 of those. I bet you it's one of these. R12, 300K, double check. Yep. R12. Next up. Yeah, sometimes I will change the orientation of a resistor when the layout kind of calls for it. Like I needed to get a trace around here, and if you go horizontal, you get a lot more space in between your pads, and it gives you a little bit more comfort room, a little bit more space for that trace to go underneath. But you got to make sure. Okay, so R10 is 47K. Also have R8 right underneath of it. Looks like R8, and that's also a 47K, and looks like that's coming R8. I gotta make sure the R is blocked by a pad, but I just see the number 8 and nothing else. I can double check that to make sure that is R8. Let's see if there's an R8 coming off of. This is U3, that's pin 14, R8, U3, pin 14. U3, pin 14 has, yeah, I see R8. So having the schematic available also helps you to be able to make sure that your parts are where they're going to. So that does make sense that would be R8. So R8 and R10, R8 and R10 are both 47K. And where are the 47K? It's up here. Needed 2 of them. Okay. Actually, even though this one looked like it was a horizontal, it's actually too small for it to fit horizontally. I still have to insert it vertically. Okay, so R10, R8, let's mark those off. Shoot, yeah, you reset that. R6. 22K. R6, 22K. 22K. Where in the world is my 22K? I don't even see that in my list. Oh, there they are. There's 2 of them. I don't think I've used any of those yet. It's probably these. Get that down a little lower. Yep. There's 22. So R6, 22K. Vroom vroom. Alright, so next up, scratch off R6. And using a highlighter to mark these off is nice, because if you use like a dark pen or a pencil, you cover up your values, and by using a highlighter like a yellow one, I can still see everything, and I can reuse this without marking up the numbers and the values and such. So R25 is a 15K, and there's 2 of those. 15K. I bet you that's these. Double check. Yep. So 25, did I bend those pins? Yeah. 25 was a 15K. Let's mark that off. Okay, next up. Before I go up north, I'm going to work my way over. So R39. R39 is a 470K. It's one of these guys down here. It's this one. It's the last one. Just want to double check. Double check. Yeah. So what was that one? R39. What would be next? No more over here. Looks like all that. Okay, let's start working this zone. Ugh. I know that one's R13. 30K. And a lot of 30Ks. I think this is the last 30K. R13 is done. Next shoot, that's blocked. It says R2. It could have another digit after it. And that's R11. So this one's this is R2. It's coming off a C19. I might have to look at the schematic to verify that. But this R11, I'm pretty certain that that's R11 right there in that orientation. R11 is 300K and 300K. I bet you that's this guy right here. Yeah. So R11. Alright. Alright, R11. I'd say populating the resistors is probably the most tedious part. R9. R9 is 47K. And that was, where were those at? Those are at the top here. Just double check. That's 47. I should know this by now. So what was I doing? R9, 47K. Yeah, aside from having to deal with troubleshooting, if you do accidentally put a resistor in the wrong spot, it's also just a pain in the neck to desolder because there's a likelihood of damaging the solder pads and your connections when you have to desolder a part. So it's kind of a pain in the neck when you do that, and depending on the kind of part it is, it can really booger it up. So R9 is done. So over here, there's, looks like, is that R5? Yeah, I hate guessing. R7, that's definitely R7, so that's 47K. That's the last one of those. I'm getting down to it, probably less than about a dozen resistors left. Alright, R7. Next up, that might be R5. Yeah, that's the only one that's left that's got a 5 over here. There's R35, but that's definitely not, it doesn't have a 3 in there, so that's R5, and that is 22K. And that pile was up here. I think that was one of these. Double check. Yeah. Yep. Okay. Scratch that off. Alright, next up. Here's one up here. It says R, it looks like a 2, and then the number is cut off by a soldering pad. See now, and laying out this PCB, I should have called that and moved that footprint up here where there's clearance room for the screen printing of that. And I could have clearly seen what that was, but I can't. But I'll deductive logic. It looks like there's only so many. Oh, there's a bunch of the 20s left. I'll just hold off on that. This one says R35. That's this one right here. R35 is 100K. And I'm pretty certain that's these. Only one of those left. I know that's 100K. I know it. R35. Let's see what else we got. R20 what? Yeah, I just don't know what that one is. I could look at the schematic, but I might just wait to see until I only have one left to do and just process of elimination. So I think everything is good. Come back to that one. Alright, these are easy. R26. 1.5K, and there's only 2 of those. R24, so R26, R24, R24 and 26, so 1.5K. They're like 4 up. There's 2 of them. I think that's these. 1.5. Okay, this is 24 and 26. Mark those off. R23 is 15K. I've got 2 of those. Use them. It's probably this one right here. Yep, that's it. So it's nice to get all your resistors laid out. In the past, sometimes I would just get up and get it piece by piece. It takes a lot more time, or at least, you know, try to get them all put into a single pile. But I laid them out, and then based off of the frequency in this build of materials, and that kind of helps me with sort of keeping track of which ones. You know, if I had 6 of that value, I made a list here of each one of these. Like, oh, I have 47K. There's 6 of them. And then in this listing is how I laid them out over here. And so it's kind of been helpful with keeping track of where out in the pile to grab from. What was I doing? R23, 15K. Alright. 20, ooh. Okay. Anything over here? No. Okay, so we got 27, 28. 27, 28 is 1K. 37, 38. 37, 38, those are 1K. And then 41, 42, those are also 1K. Those are all 1K. I've got 6 of those. There's only, yep, that's these. So all 6 of these up here are the same value, so I can kind of, don't have to worry about measuring them or double checking. I can fly through them. I guess I just pull those off. Normally I would flip this in a way that's more just easier for me ergonomically, but I don't know, trying to capture video of this, it's kind of hard to tell what's the best angle to do that at with trying to capture it. Oh well. Alright, let me mark those off. 27, oops, 28, 37, 38, 41, 42, and I've got R12 and R29 left. That's probably R29 over here. And then where's R12? I did R12, and there's only one resistor left. So okay, so this must be R29 over here. It's because it's the only one left. Here. All right. Oh boy. Hard to get to. Okay, all those are populated. All right. Ugh. I'm just sticking your face right into that. All right. So let's do some soldering. Now for soldering. Now this soldering tip has been sitting for a while. Jeez. So I'm just going to load a little solder on it. and then clean that off. Because when your tip isn't shiny, it doesn't transfer heat very good. Okay. It's like the rosin on here kind of cleans the tip off. And now I've got a nice shiny tip again. I like to use the chisel tip. That's my preferred tip. I don't like using a conical, which is like the little pointy one. I think soldering is, I enjoy soldering. I've gotten it down where I'm pretty confident about my quality of work, knowing how to get just the right amount on there, and I kind of find it relaxing, really, as long as the work is easy to access. But when you have a bunch of parts, like when you have a ton of these on here, it does get kind of difficult to access all the pads. The thing about soldering is you got to get in there and kind of, with the tip of your soldering iron, be able to kind of touch the pad and the lead coming out, get them both nice and hot. And for me, the chisel tip kind of helps with doing that. But really, it's probably just a matter of whatever you get used to. If you get used to using a conical tip, like little pointy tip, it's actually probably easier to get down into between the lead coming through the pad and the pad itself. But I've been using the chisel tip style soldering tips now for years. I've gotten very comfortable with that kind of edge. Sometimes I just stop and go through and I trim the leads that have been soldered already, just to make it a little easier to get around on the board. I don't even know how well the microphone's picking me up. Another tip about when you solder these connections is you kind of have to get them properly hot, because you can actually just glob wet solder and it'll just instantly just stick to it, but it actually didn't go down into the pad and sort of wick onto the other side, and you don't really get a really great soldering connection. But if you get your lead coming through and the pad to the right temperature, it has that, what do they call that, capillary action, where it'll wick, the solder will wick down to the other side of the board, and you'll get a really good connection. But sometimes if you have a lot of solder blobbed on the tip of your iron, it'll just instantly just suck right to the area, but it won't actually be hot enough to pull down through the little cracks in your pad to get down to the other side. I think I've gotten everything. Oh no, here's these. Sometimes when you're applying the solder and you get a little bit too much built up on there, if you pull up onto the lead, it kind of removes the extra solder instead of leaving it being a big blob of it right there at the pad. This has got a lot of leads sticking up, and it kind of can make it hard to get a nice easy access. But I mean, if you can get your soldering tip on the connection nice and good, a lot of times you don't have to fuss with all that. You can apply just the right amount of solder and not get too much. Sometimes adding solder kind of helps with getting heat to the area and helps flow it down through. But with all these leads sticking up, it can be kind of a pain in the neck because they start to prevent you from getting your tip all the way down. The edge of the leads are hitting the part up here, and then you can't get it down all the way, and it's just hard to get a good angle so you can get that heat transference. Alright. I think I got them all. Now I'm going to trim them, which I don't know if this is in shot. I can't really get it over here too much. Maybe that's getting some of it. Oh well. I mean, I'm just snipping them so that there's just like maybe like a millimeter of the lead sticking above the soldering connection or the solder work. Alright, now I like to just do a little visual inspection. I don't think I missed any, but just to double check. Sometimes what I like to do after I've trimmed them is take the soldering tip and just reapply heat to just reflow it to make a nice clean look to the soldering connection. Sometimes if you did have a little bit of a blob and you cut that, it'll look like it'll look like an actual tree stump instead of it coming to a nice point. But everything looks alright. Okay, so I think I'm going to populate the next things. I think I'll do... There's not much more. Still going to be a long video. Okay, so next I'll do the caps. So the caps, I've got ceramic and I've got film. And I've got a few electrolytics. I'll make a pile of the ceramics. And I believe, so what was the, I made a list up here. So there's two 560 picofarads. There's here. I got five. There's two of those, and I got five 220 picofarad. That's here. I got one 330 picofarad, two 1500 picofarads, and then I got four 10 UFs, and then 1400 nanofarad film caps. Those are all the same, and there's only one value for all those, so I can just populate those without even have to look at the list here. Let's drop them all in. With these, I like to try to keep the info that's on the top of them all in the same orientation. Doesn't matter. They're not polarized, so you can put them in either direction. But just when you look at it, it's nice when they all are facing the same way. Okay. With soldering these, I kind of have a process I've gotten to with these where I only solder one lead at a time, and then I flip the PCB and I make sure that that's not crooked, because once you solder both legs and it's crooked, it's pretty stressful on the part if you want to try to straighten it out or make it look nice and neat. Where if you only solder one leg and it's crooked, you can still bend it and it won't have take so much stress onto the the way that the capacitor is constructed. Oh shoot! I just realized something. Some of these footprints, even though it's a square or a rectangle, they're not all these style caps. Some of these I use the same footprint because it's the same width for the lead distance. So actually I should probably do all these ceramics first. So down here we got C3 and C4. Let's verify that. C3, C4, both are 100 nanofarad, check. C6 is 100 nanofarad. Alright, then C23 and C17. Ah, yeah. These are not. Alright, so I'll pull those back out. No big deal. They haven't been soldered, so. Okay, so C23 is 560 picofarads. C23 is the 560. That's this guy. Okay. C17 is 1500 picofarad. That's this guy. Okay, mark those off. 33, no, 23 and 17. C23, C17. And you got C3, C4. C6. C5 is 100 nanofarad. C25 is 100 nanofarad. Okay. I don't know if you can hear those church bells. If you can hear the traffic. C25. C5. Did I bend those? Yeah. Okay, next up. Yeah, the thing about the church bells is through the week they play it through a loudspeaker, so those are just like recordings or whatever, but on the Sunday service it is the actual church bell that they ring. C21, 330 PF. C21, 330 puff. 330 puff. C21. Cool. C18, C28. C18 is 1500. C28 is 100 nanofarad. Alright. Okay. Mark those. 21, 18, 21, 28. C21, C18, C28. Alright, C24. C24. Let's do C22 first. 220. C22. Oops. C15 is 100. C27 is 220. Dong. C15 is 100 nanofarad. Okay, C24 was 560. Alright, mark those off. Only got 3 of those ceramics left. C27. C15. C22. C24. Okay. Alright. And let's see. Where are those 22 20s? We got 19, 20, and 26. So 19, C19, C20, C19, put this down a little bit. C19, there's C20, there's C19. C19 and C20 are both these guys. And C26 is the last one of these right here. After that, there'll just be all these. I don't even have to look at it anymore. Just pop them in. Okay. Now these. Oops, that's getting loose. Yeah, another thing I noticed with getting the shakes with this too, I think has something to do with how much sugar you've eaten. I feel like if you've had a lot of sugar before you start doing this work, sort of the come down from the sugar in your system can give you a little bit of the shaky shakes. And if you're, where's that loose? Is that up here? Dang it. Pain in my ass. Okay. Yeah, so sugar and coffee work against you. They might give you a little perk to do this work. But when you kind of come down off of them, unless you just stay steady drinking them, but even then I feel like you get too buzzed out on sweetened coffee, it can give you the shakes. I've been trying to reduce my caffeine intake to the point where I haven't even drank coffee for a while. It's been a few weeks since I've drank the dark brown bean juice. I'm not like against it or not liking it, but excuse me, I'm just experimenting. Alright, so I got all those caps done. I'll put in these electrolytics. So, oh, fudge. Now with electrolytics, these are polarized, and they're indicated with a little white band to let you know that's the negative side. Where'd that go? Found it. I use Nichicon brand. I'm using low profile. When the prototype build, I used the more common height. I think it was like 11 millimeters or something. 12 millimeters. And I thought they were just protruding too far up and were vulnerable to getting hit. So I had some of these lower profile ones on hand. These are 10 microfarad rated at 25 volts, which this circuit, the power supply, is plus and minus 12, so we are just fine on that. And I'm only using electrolytics on the power supply and on the audio inputs for decoupling. The less electrolytics there are, I feel like the better off you have, or the better off you are. Where, you know, electrolytics are, you know, they have a shelf life to them. They can dry up, they can fail. Just seems like the less of them you have in a circuit, the less risks you run into. But you know, when they're needed, you got to use them, like in the power supply. Alright, so I've got all those folded. I guess I can do some soldering. Now here again, I'll go back. When I do my capacitors, I only solder one side of each capacitor first round, flip it over, make sure they're all they look oriented right, so they're not twisted or in a weird position. And then I get them all straight, and then I flip it back over and then solder the other side of them down. This is when it's really nice to be wearing eye protection, because this is pretty comfortable for me in terms of the height of my workbench. I can get the work real close to my face, which makes it, you know, it's easy to see what you're doing very closely. But it'll put you at a lot greater risk of having solder or rosin splash up into your eyes. You know, you only get one set, so it's really important to try to protect them. I don't have any workers' comp when I do this kind of work, so not that that would probably matter. Even if you did, I don't know, you probably have. I'll just shut up. I think I got them all. Okay, that'll look good. Yeah, they all look good. Cool. Finish it up. Can I do this in 1 minute? Alright, I think I got them all. Alright. Just snipping off the leads. Cool. Getting down to it. What else is left? Okay, well, the rest of this stuff up here, I've got sockets and pots. In order to solder these in, I need the face plate. So the only other part then to solder in are these trim pots here. I'm not even going to turn the... And no. The hell if I want to breathe that crap in. I have this vented to the outside, so it's not even just it's a fume extractor, but it really is extracting it like out of the workspace. Cool. Alright, I believe the next step is actually going to be, since these parts go on this side, once I get all of these on here, it's going to be difficult to clean all this rosin off with all these parts on there. And I use acetone. It's pretty well have a little jar of Q-tips, and I put acetone in one of these little bottles like this. It's got a little needle tip on it, and I'll sometimes saturate the area. Sometimes I just saturate the tip of the Q-tip. If you pre-saturate it, it kind of softens it up and you can wipe it up real easy. But when you do this just on the Q-tip, you can be real precise with the movement. And I've also taken cotton balls and soaked those and just gotten it. And that kind of does a lot more, cleans a whole lot more, a lot faster. And really, why take more time with this if the end result is the same? Where I just really want to get all this flux off the board, this old rosin. It's supposed to be safe to leave on there. You don't have to clean it, but just for presentation of it, I just think it looks a lot better when you get all that crap off of there. Let me see if I can get it kind of close here, and you can get a kind of see like a. And it's just a lot of gunk on there, and maybe on certain angles it doesn't look too bad, but looking at it in person, it's ugly. You put all this work into it, you're like, why wouldn't you want to clean that up if you don't have to? I understand, not everyone's going to, but I would rather have my work look nice and clean, especially if you're going to put it for sale on the internet. Someone sees that. I think that work is appreciated, but in a pedal, it's enclosed and you don't really see that. But with this being a concept that's for Euro rack, it's exposed, and when they see that, they're going to see that when they get the module, and then they put it in. You have to install it in their case, and if you got all the flux on there still, and it's a lot of it, it just looks like, you could touch it and it would get on your fingers, and I wouldn't want that. So I want to take the time to clean this. I think I'm just going to do Q-tips and just work it in sections. I like to cut the Q-tips in half. I may not even need this many. Put those over here. Put all that to the side. And get rid of this. Now, because acetone is pretty gnarly stuff, I don't like breathing it in. I don't want it, aerating into the workspace I'm in. That stuff is no bueno. So I use my fume extractor, again, which is vented to the outside, so it's sucking it through the filter, but piping it to the outside air. So greatly reducing how much of the VOCs from this are being inhaled by myself. Again, I'm wearing eye protection, and that's especially important in this stage because this stuff can splash and bubble, and not bubble, but you can get little splatters or whatever. And acetone on your eyeball does not seem like a very good idea. So let's see how fast I can do this. Some of these I can see little splatters from the rosin or the flux or whatever you want to call it. When you're, hey, well, it's taking the purple off. That stuff will splatter and you'll get little droplets in areas where you weren't even soldering. Because of that, that's why I kind of believe that wearing eye protection is important, because that stuff could be splattering in your eye and be like the perfect temperature where you don't even feel it, you know, where it's like the same temperature as like the surface of your eye. And if it's really small, you probably wouldn't even feel it splatter and get in there. Is that an irrational concern? I don't think so. See, after so many spots, the Q-tip tip gets a little wore out. It also starts accumulating the rosin, and so instead of cleaning it up, you end up just kind of smearing it around. I've used a toothbrush before, but that's kind of messy. To me, I feel like this Q-tip is just the best way to do it. Also, see, if I use this hand, will you still see it? See, I don't want to block the side camera here, so I'm just sticking with my left hand. But also, I've noticed too with these PCBs that the black PCBs are like almost like a matte finish, where all these other ones like purple, green, which are blue, really the only other ones I work with, have more of a little bit more of a glossier finish, and they're harder to get like nice and clean. Like there's something about the black ones that usually, the black PCBs that are the matte finish, they just clean up a lot easier. Where if these shinier ones with more of a gloss to the protective coating, this purple, you know, like this is purple, and it'll be like showing the streaks a lot more. And maybe I'm a little compulsive, but you know, you just want to try to get it all off. But with the black PCBs, it just cleans up easier. And I thought I told myself that I would just stick with using black PCBs for the circuit boards, specifically for that reason. And yet with this, the first one, the prototype board was black, and then I added these trim pots, those little blue trimmer pots, to the resonance portion of the circuit for fine tuning to get oscillation and all that, and have it be symmetrical. And when I was ordering the PCBs, I was like, oh, I should do purple, it would look so cool. And then I was like, I got them, I was like, oh shoot, yeah, that's right, I forgot. They harder to clean. Like even once you get all the goop off, it has all these like ghosts and like these like these streaks, real streaky, and you have to keep using like a fresh Q-tip, or otherwise you just end up just changing the way the streaks look, but you don't actually get up any more of the what's there. Tedious. That one's shot. Yeah, with using this, see if we can. It's probably gotta get closer. I'll wait till it's done to show it close. But with using this fume extractor for this stage, you know, the fumes are hopefully mostly going up there, and not in my workspace and into my lungs. I don't even smell this stuff when I use this extractor here. All this is right here is dryer duct, and the Heiko even though I shouldn't say the brands because they don't sponsor me or anything. I'm not gonna try and give them free advertisement, but it's just your run-of-the-mill Amazon. You know, if you look up fume extractor, they run the game pretty good. It's that blue thing, and I've customized mine to actually have ducking go to it, and to intake it, and also ducking coming off of it as the as the exhaust, and then that goes to the outside. I also have it on a switched outlet, so I can just flip a switch instead of having to go down to the actual fan housing to flip its little on and off switch. I have it down on the floor low, so I don't have to hear it up close. I used to work with that thing like right up onto this like that, and I'd feel like I'd get headaches having to sit next to a damn fan running for like long periods of time. In projects where I was building multiple of something like pedals and stuff, I could have my head next to that thing for well over an hour. It was driving me crazy. Hated it. And I desired to have something like this where I could kind of have the unit further away and use ducking to kind of be what I move around to extract stuff. Oh crap. I don't think this is taking 8 minutes at least now. Restart the camera. Once I get the majority of this all with the Q-tips, I'll probably take a cotton ball, or you can just use an old piece of cloth, like sometimes like old socks, and just saturate it with the acetone, just wipe it, and it can usually do a pretty good job of getting everything. If you did this from the start, it would just kind of be pushing all that rosin around, and it just doesn't look as good. You have to go through a couple cotton balls, and it kind of ends up just spreading it around. It gets real ugly and messy. It almost feels like you need to get it all mostly off with the Q-tips. I'm pretty happy with that. Alright. Oh shoot. Yeah, I'm not going to reuse that. Screw it. Alright, and then the final... Ooh. And then another thing I like to do is take an old toothbrush and just kind of... This helps get off a lot of the loose cotton. I'm probably breathing that all up. Dang. Go in different directions. That kind of gets off all the little loose bits of cotton from that cotton ball and from the Q-tips. A little circle motion here. Not bad, not bad. I think we got it. Alright, let's get a close-up on this thing. Okay, so I got all that flux off now. I hope that's like a good focus point. Alright, just inspect all my solder work. If there's anything that looks kind of ugly or problematic, I can just take the soldering iron and touch it, make it look good. And I'm not seeing anything. I didn't miss any spots. But I probably could get a couple of these looking. What's this guy doing? What is that? That's good. That's good. So next I need to put on the jacks, the pots, and also this side will be the power connector. Okay, here I am. Here's the face plate, also PCB material, but the black finish. Let's see if I can get a little close up on here. This is called the Stereopathic Oyster, and these right here are oyster shells. Now that I've got this part, just got to make sure what's gonna. I guess maybe I should put this part on the power connector. Alright, need to check, make sure all my pins are good. They're good. Is this seat in there? Yep. Seat's in there good. Alright, I'll just take a moment and clean up the flux. Whoa, it's bubbling the acetone. It means those pins are still hot. Pins are pretty thick on these power connectors, and I think what happens is they hold that heat for a while. Now let's stick the parts in. Just double check the work. Make sure I don't have any bridge solder connections. That looks good. Now let's drop these other things in. So this one has a nut. Take that off. It also has a little locking tab. We'll take that off. Actually, use snips. Another reason you need glasses, because that would have. Who knows where that's going to shoot off to. This is the only one that's like that, so that has the nut on it. So I know exactly where that goes. Okay, that's seated. And then these I got two of these. These are green. These are A100. I know where these go. These are the audio trim. Just double checking. A100K is level, input level. Input level is inputs left and right. That's sockets. Level inputs. So that's these guys right here. So these go right here. You gotta kind of pinch these little supports just a little bit inward for these to go in friendly. Just a little bit, not too much. Otherwise it really stresses out the board when you push in the board to get them in. There we go. They look flush. Okay, now for the resonance controls. Resonance is B10K. So, great. These don't say B10K. See B104 and B103. Okay, so I need to get the multimeter one there. And go up. So, I bet you B103 is the 10K. 10. Yeah, B103 says 10. B104 should be 100. Yes. Alright, that's confirmed. Cool. B104, B104, B103, B103. So resonance is next. Resonance is the B10K. So same thing with these. Bend them in just a little bit. And snap them in. Just snaps right in. Cool. And then these are the CV attenuators. CV, those are the B100K. So those go down here. A little bit more. That. This one. Be careful. Alright, getting close. Now, we'll put all of our sockets in. 3.5 millimeter jacks. Okay. Is that? Yeah, it's in there. Alright, now we drop the faceplate on. Someone's holding me up here. There we go. There we go. So drop this nut on. I think that's 10 millimeter. Make it just slightly snug. And then all the jacks. That's not the right size. This is the right size. Getting close to the finish line. Once I get all these soldered, then I can drop the ICs in, put my knob on, and I should be ready to test it. Not really certain how I'm going to demonstrate that since I don't have a Eurorack case up here. And it would feel kind of wrong to do this whole assembly and not show it performing to verify its success. So I'm going to have to come up with some kind of way to do that. Now part of this step too, by using the faceplate and these nuts, is that it gives you a chance to make sure everything is seated nice and straight. There's a little room for play, and all these nuts kind of help lock everything in a certain place so that you don't have anything rubbing. Looks like everything is clear. Another thing too with these, it's at this point, since this is going to be something I would be marketing, putting online to sell, I definitely don't want to booger it up or anything with smudgies and everything, or scratch it or anything of the like. It's very stressful, kind of, actually. It's very easy to do that stuff. Scratch it, mar it, whatever. Fingerprints you can rub off, but scratches you can't. So I got everything. Looks like everything is snug. Looks like all of my trim pots are clear. Try those all out. Okay. So I think what I'll do is I use these little foam things here, make sure there's nothing metal in there. Stick this face down, and I'll do all the sockets first. Okay. Okay. Just double check everything. Everything looks good. How can I do this so that I can make sure that's not... Give me a tool. I think we're good. Okay. Ugh. Jeez. Okay, now to remove the solder. Or not the solder, but to remove the rosin, the flux. I've seen some people use isopropyl, which I think is, it's definitely milder. It's less aggressive. Acetone can melt plastics, where isopropyl is not that aggressive. But I don't think the isopropyl removes the fluxes nicely. This just gets it done. More caustic, for sure, That's why I'm using ventilation. This side's really important for presentation because this is the side you actually see. The other side is covered up. So unless you disassemble it, you really won't see that side. But still, it's been cleaned. Now I'm working on this side. I mean, performance-wise, this will be in a case, so you won't actually see this. But in terms of the user that ends up putting this in their case, they will see it when they install it. And I just want it to look clean. Clean work is also easy to work on too if you ever have a problem, if you ever want to change anything. I wouldn't be sending anything out that isn't fully functional and has any problems with it, but what if this is still around in 25 years and those electrolytics are, they give out? You gotta put some new ones in. I guess it really doesn't make that big of a deal with the solder, the flux being on there. It's still just as easy to remove parts even if you leave that on there. There is the concern though that stuff over, you know, the course of time, maybe in 15 years, 20 years, that flux could become potentially conductive, and that could definitely affect the performance of a sensitive audio circuit like this. Ugh, leaves all these streaks. Because of how strong this acetone is, you do really have to be careful around some parts. You can actually rub off the, I can see a little bit of blue on here. Maybe one of these resistors I got a little too friendly next to, and it rubbed off a little bit of the blue. Not a lot of it was on there, but where it really gets sensitive is the markings on electrolytic capacitors. Those things, like the labeling, they're very sensitive to this stuff. You'll take off the markings on the capacitors real fast. So you have to be real careful when working with the acetone around electrolytics, because you could rub off the information that tells you their values. Fortunately, there's not a lot of them on here, but and do like more too. I told you I'm recording. This is where it gets real tedious. Gotta be real gentle, not to hurt any of the parts. But it seems like when you get down to this point, you just can't get all the streaks off, and you almost have to use like a fresh Q-tip for every spot. Well, I'll do one more round. Actually, maybe I'll do this guy. I think that looks good. Okay. All my lines look straight. The pots they look flush. Everything looks good. Nothing looks stressed. All right. There we have it. Well, let me set the dial on there. Do I have that? Okay, so I think what I'm going to do is finish your thought, Brad. I need to figure out a way that I can present the testing of this. Okay. Oh, it's rubbing. It's also got to come out a little bit. Okay. I think it's about straight. Snug it a little bit. Oh, shoot. All right. So, overhead shot. Let me get a... So, there it is, fully assembled. We'll flip it over to here. Oh, not fully assembled yet. I gotta put the ICs in. Okay. Alright, so here I've got 4 TLO 7.4s, the quad op amps. I've got my TLO 7.2, the dual op amp, and here's my quad VCA. I'll put that in last. I'll put this little guy in first, and I'll roll it. Get those pins perpendicular. And there's that. Drop that in. Okay, I'm gonna get these guys out. Alright, now drop them in. Okay. Alright, well, I've got all the ICs are seated. All my pins are clean. Everything's good. Knobs installed. Now, I need to test it. Now, one thing that will need to occur is I have, I don't use metal, I use a plastic tool for this, but these trim pots here need to be adjusted, fine-tuned, so that the resonance behaves the same on both of these circuits. But it's going to require, I got to figure out some way to be able to power this and then put audio into it and have audio go out and just verify that. So that's going to require some brainstorming. So here's my sort of just quick testing setup. I've got a Eurorack skiff. I have my Stereopathic Oyster in here. I have a blank panel, something I've made. I have a few designs I've created and plan on putting those in my shop in the future. And I have here an LFO by 2HP. Basically all this does just generates a variety of different low frequency oscillators that I can feed into the CV inputs to test how the CV sounds. The inputs, I have just a basically RCA to 3.5 millimeter adapter for my left and right, and just a stereo plug that goes into my headphone jack of my vintage phone. And let's I want to play some music off of here, run it into here. Now this can handle Eurorack signals, but I have these level knobs here. Those can attenuate, so if your signal is really strong, you can dial it back, and it works great even with line level signals as well, based off of my experience with the prototype. So Right now I'll take the resonance, dial them all the way counterclockwise, which is like no resonance, and I'll have the levels both set at noon. And I'll initially be coming out of the low pass output of the left channel, and I have that going into a little small guitar practice amp. So the tonal quality isn't really the key thing in this example, as much as making sure signals passing through and the behaviors are within range. There are trim pots on the back that need to be adjusted for oscillation, and having left and right both kick into oscillation at the same point when you have the cutoff at a certain position, but they should go into oscillation even without dialing them in. They just may be a little different, but I'll fine tune all that once I just sort of verify that everything's working as it should. Alright, turn this on. Alright, so these are lit. Got power to it. I have audio ready. It's going to go into here. I'm going to turn it all the way clockwise, which should be fully open, no filtering. As I dial this counterclockwise, it should roll off. Since we're in low pass output, it should roll off the high frequencies. Alright. Turn the... Sounds right. Let's add some resonance. We'll go to about 2 o'clock. Go about 3 o'clock on the resonance. Alright, so that's low pass. So basically low pass output, you just sweep away the high frequencies and leaving only the low frequencies. Band pass is sort of just focuses on the mid-range, where you get that at about noon. And then high pass pretty well will strip away all the low when you dial it fully clockwise, so it'll only be the high frequencies. So we'll try the band pass. See, there's your band pass. Sounds about right. Sounds like what band pass should sound like. Okay, let's try high pass. So there's no. Now for me, this project was essentially so I could have a stereo low pass filter designed for performance, meaning a large knob for interacting and being able to quickly just do filter sweeps, and primarily for low pass filtering. My preferred filter for a lot of the types of production I like to do. So let's have the cutoff all the way down. So let's try the CV inputs. So these CV inputs, CV1, CV2, both sum and affect the cutoff for both left and right simultaneously, just like this one cutoff knob affects both left and right simultaneously. Now the resonance control is individual for each channel, and you can run two different signals in here, say drums on one and bass in the other, and then on the output you would just get the drums on the input of the one that you had drums in, and the side that you had the bass on, the output would just be bass. But for me, again, just typically running stereo filters, so or stereo inputs like full mixes, samples, things like that. It's kind of was my anticipated use with this. So anyway, we have the resonance. Turn the resonance back up so we get a little bit of that cue, a little bit of that gristle when we do a sweep. Without resonance, it's a pretty flat pretty flat response. So we'll go up, push the resonance. So that sounds cool. So we're going to use a LFO here. Alright, that one works. Alright, so the CV inputs are working, that's good. I think everything is good. Alright, so let's try self-oscillation and see how that works. Alright, and for that, let's see. Boy, it's a strong signal going into that amp. Let's try it on this channel. And so basically, in order to get the self-oscillation, you want to take your resonance and, well, we'll just full clockwise. Yeah. If it's about if it's just slightly backed off, you won't get that self-oscillation. You just get a very high resonant peak on your filter sweep. But if you go full blast on resonance, you get the self-oscillation. I could have a lot. I'm just having a little too much fun with that. Well, I think everything is good. I'm not really surprised because this isn't like the first build of the circuit and everything. But this is I did add trim pots to the back, which I pointed out in the build. But just that slight change, just wanted to make sure that everything's good. I will go through and do a fine tuning on this so that the resonance is nice and balanced between the two. If you have you know, the same level inputs going in left and right, and make sure everything is symmetrical and tight. I'm going to build a few of these, and whether, I guess, probably hopefully have that done before the new year. And I'm not certain when these will be available in my shop, but that's the plan, and I'm doing my best to work towards that goal. And but I think I've succeeded in building the Stereopathic Oyster. It's probably going to be like over 2 hours long in video, even if I edit it. Anyway, thank you for watching, and have a good rest of your day. Oh yeah.